Introducing the IFOBs, an integrated fire control optic and ballistics solution by Aerotrack Research. Designed for soldiers on the modern battlefield, IFOBs integrates advanced ballistics calculating systems which provide real-time feedback and precise bullet trajectory. It displays an aiming point in conjunction with the red dot sight for the shooter, regardless of target distance or rifle positioning. With our optic, soldiers will no longer need to mentally estimate and calculate ballistics parameters under stress while engaging targets. A traditional red dot optic is zeroed at a specific distance, which means the bullet will hit the target at that distance when the rifle is held completely upright. However, this is not the case at different distances as gravity pulls the bullet towards the ground over distance. At ranges closer than the zeroing distance, the bullet will hit slightly low due to the difference in the height between the bore of the barrel and the optic. At long range, gravity and drag will make the bullet hit low. Learning how to estimate the distance and compensate for these factors unique to different rifles can take shooters a long time to master. In certain scenarios, the shooter must make shots at an angle to reduce their profile to an enemy or to aim around obstacles. If the shooter is not able to fire with the rifle upright, the bullet lands in an unintuitive location. This is why shooters are generally taught to keep the firearm upright. Due to the slight angle between the rifle barrel and the red dot, the bullet will hit significantly lower and veer off towards the direction the rifle is canted. This is extremely difficult to mentally calculate under stress and is the reason why shooting with the canted rifle is not preferred. Let's put these concepts into real-world examples. Here, only a traditional red dot sight is used to make shots at this target at various rifle cant angles. This results in groups that land low and on either side of the target based on cant angle and distance. IFOBs addresses these issues with sensors that measure the distance and rifle positioning to calculate and display the point of impact intuitively to the user. This allows the shooter to primarily focus on aiming the rifle rather than estimate a complex ballistics equation for the bullet trajectory. IFOBs comes with everything the user requires to become an effective asset on the battlefield. It can be easily mounted in front of a red dot optic and provides ballistics data in real time to the user. Just clamp the IFOBs onto a standard Picatinny rail and tighten the two screws. The distance lock button connects to the front of the IFOBs and can be attached using the provided adhesive Velcro strips. It is made from durable 6061 aluminum with a steel protective cover for real-world conditions. A laser rangefinder to measure distance is integrated to the front, and accelerometers are used for rifle positioning. This data is used to calculate the bullet point of impact, which is displayed to the user on a transparent OLED display. IFOBs can be powered on with the bottom button. Looking through the red dot, the distance is shown on the top, the elevation on the right, and cant on the bottom of the reticle. When the distance displays dashes, the target is out of range. Our maximum range is 180 meters, which is an appropriate engagement distance for a .22 long rifle bullet. The buttons on the right change the reticle brightness, and the current setting is displayed temporarily on the left. If both buttons are held for 1 second, the minimal mode is toggled for a clear sight picture. To use the IFOBs, point the red dot on the target and lock the distance by pressing the aim lock button. Next, align the red dot with the blue crosshairs, and the blue dot is the calculated point of impact. This blue dot will be placed on your intended target and the shooter can begin firing. The aim lock button is a necessary part of the system, as adjusting the reticle to the target may also move the laser off of the intended target, leading to an inaccurate distance measurement. When we cant the rifle, we can see the calculated point of impact move towards the side it is canted and below the point of aim as expected. Now, let's take a look at how IFOBs performs. As we can see, IFOBs compensates for the distance and rifle cant, which results in accurate and effective shots on target. Compared to shooting with only a red dot, we can confidently say that IFOBs succeeds in making the shooter a more effective asset on the battlefield.